Okay, hello everyone. For today you will be using multiple collections, such that firstly you will have to store inside an array list a person, and you have this person characterized by a name. You have CNP, which is the personal numerical number. You have an address for this person, and you want to have five objects where two objects have the same values. Okay, and in this way you want to store them inside an array list. You want to parse it using an iterator, such that you can also parse it backwards via ListIterator, and you can also add in the middle of the list a new element. Also, you will want to compare the objects using this iterator, so you have that comparable class, which maybe you can remember since last time. So let's see. First of all, we need a class person. Okay, and these are the examples with iterator and how you can parse. Okay, but until that time, let's declare this person. So we have name, personal numerical number, and address. Address can exist as a different class, but this is not quite the scope of this exercise, so I will declare them as strings. You can do like in the first laboratory where address was a different class. You can also save it like that. Okay, so if you want to have it as a different class, let's see. You want an address because an address is characterized by a private string. We have street, then we have a private int, we have a number. Even this number sometimes can have letters, so it can be again a string. Okay, we have a private string city and country. And now we use generators to be faster because it's not quite the scope of this lab. Okay, let's see. Generate getters, setters for everything to have access to it. And when you want to display it, you don't want to see the address and to use a lot of get. It will call by default the toString of everything. Good. So this is what your address should have. I will paste it here. So basically you put just the attributes and then you use generate and everything is solved for you. Then we have a person, and the person also has an address, let's say A or ADDR, to know what's that A. So always use this kind of variables which have a meaning. Okay, don't write something which doesn't mean anything. So let's see, generate name, CMP, address, constructor for everything, and getters, setters, tuck. Then we have the toString. Let's see. Equals with hashCode, which is after. We would like to have them to process them. So what you can have is a driver class. Well, usually you have the driver class such that you have the behavior, and you have each and every class which is separate. And for it, you have a driver, let's say for this person. Driver meaning that it has a void main. And here we have the public static void main. And you know that this is the class which has the whole behavior of your application. So you don't need to search, oh, where is it? Is it in address? Is it in person? No, you just know that you have the whole simulation here inside. Then we want to have an array list. So we use a list of objects of type person. And we have persons, which is new ArrayList. Okay. These need to be imported Okay, from Java util. Both are from Java util, so I can put a star and they are solved. Good. Now we need to create several objects. So we have a person, P1, as being equal to new person of. And now, as you can see, it says that we should add the name. So let's have person called Ionel Popescu. We have some CMP, what, 299, and something like this. Okay, and the address, new address of, and we see that we have a street. Let's say it's Technica. Okay, let's have it like this to see what I'm. Okay, then we will have the number. The number is an int. Okay, then we were having a city. Okay, and country. Good. Then I want two persons to be the same. This is my P2. Okay, then we have a P3. Okay, a female. And we have another. Okay, this is significant. Right, tuck, tuck, tuck. There's my P4. Mm, 21. Okay. Then we have these. And now we also have the okay, and some numbers just to see that they are different. Okay, so then we need to add them inside. So with them persons dot add of P1, P2, and so on until P5. Tuck, 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 tuck. Let's see, this is 2, 3, 4, 5. Okay. Now, what I want to do is to parse it, and I can parse it using an iterator, so it will go from the first element on position 0 until the end. And this is how you can do. You just set the beginning, and then you need to have exactly this iterator that has next and get exactly the next element and to display it. Good. So we define an iterator. It's also in Java util, my UTR, as being my persons.iterator. So it is the iterator which is associated with the array list, which you've got here. Parsing a list. This is done element by element from the beginning until the end. Okay, so you have a pointer which first starts from position 0 up to the end. Then we have a while. In this while, I have this iterator, and what I need to check is whether I do have a following element. Okay, so this is like when you think about linked lists and you get them element by starting from the first position. Okay, so I would get here an element of type person. Okay, and I would have a current person. Okay, which is, I can cast it also to say that it is of type person. and it will be of my iterator dot next. Okay, so as you can see here, you obtain the object. This is abstract, and you need to say which is its type. So this is why you cast it. Okay, and then we can find out more about this person, current person. And when I print it, it will search for the toString. Let's see, toString. It exists here, so it's perfect, because else it would display the address, and I don't want this. All right, let's run this. Okay, and as you can see, we have the whole structure, person by person, and even this object, we see that it belongs to the class address, and we have them one by one. So this is for parsing a list from beginning, okay, to end. Okay, let's see. Do you have any questions up to this point? So you were just defining the classes which you want to use. A person lives at a certain address, and this is why you declare this object inside of person. And then you have several persons, and I want to add them inside this array list and to have each and every element from beginning to end. Okay. So you can ask questions. If not, I will go forward. So let's see. Here you have a list iterator. The advantage of using a list iterator is that you can parse this whole array list from the end to the beginning, and you can get any element at the point which you want. You can also add elements according to the position. You can even update the value of the element according to the index. So you can see it like a sort of circular list. You don't have a single linked list to get the next element. You have it both side oriented. Okay, so it's like double linked. And here when you can go like from any point that you want, you can see it as being circular. Good. So let's see. Now, how can you define it? All right. Here you need to think like this. You have a list iterator, and you need to know which is the type of the elements based on which you want to iterate. Well, I iterate between elements of type person. Okay, and this is list iterator, so LETR, let's say to be short. Firstly, it's null because you don't associate it to any array list. Okay, this is the case when in this example you've got an array list, but in which you store just strings. So this is why you also put the list iterator to be of type string. Okay, then what you need to have is to say that this list iterator should be associated to a collection. So this is why you have this line that you have my list iterator. Firstly, it's null, so you just allocate it. And now I want to know what I need to parse. So I will have my persons. And for it, as you can see, you will call the list iterator. You can also have the index, but I want to have the whole list iterator. So this is how I define it. Then what you can do is to go in both ways. So here you can pass through the element in a forward manner, so using next, in fact. Okay, so this is parsing. Okay. Only elements. Okay. And okay, using forward direction. Okay. So you just use the next element. Okay, so this means from beginning until the end. Okay, as you remember from your course of data structures and algorithms, you are having the first element and the last element, and you are having relationships between them to have the next, and you were using an arrow to access it. So here, in fact, you have the while. While based on what? Based on my iterator, which is in fact the list iterator. Okay, and as before, I use again hasNext. Okay, and for it, if I want to display it, I can also store it as before. So it would be took exactly this one, and I put it to be my list iterator, and I will display. So let's have separator. Okay, let's see. Here you have them again one by one. So you define it just a little bit different with this list iterator, but when going through the elements, it's done in the same manner. Now, when I want to go backwards, you see that here what happens? The pointer associated to this list will reach the last position. So the pointer will have this last position. And now you will have from back to front. Okay, so it means that you need to check what? That you have an element before your current element. So if the previous element exists, so as you can see, you have hasNext, hasPrevious. Okay, you would take that person, but in which manner? You need to move from right to left. So you need to have, as you can see, you have previous. And here means that I will have list elements from backwards to the beginning, from back to front. Okay, let's call it like this. Ta-da. So it's new line. So as you can see, you reached Mr. Alexandru, then we will have Matarina, Dragoș, Ionela, and Ionel. So they will be exactly parsed from the end until the beginning, checking whether you do have the previous element. Okay. Now it was the case when you want to add, according to a position, a certain element. So this is done also according to your current position. So in this way, you can find out which is the previous index and which is the following index. So now we would be at the beginning of your list. So we can see which is the previous element. Okay, so the previous element here would be the list iterator. And you have the previous index, so to know which is the position. And you can have the last, okay, based on the position as being list, but list iterator. Iterator dot next index. So let's see. If I run it again. As you can see, you went from backwards to the first position. So it means that the previous element does not exist. Okay. And you also have the next index, and based on the next index, it will be, as you started, the first stored person. Okay. So here, if I would want to add a new person, list iterator dot add, and we need a new person. Let's have someone from the same address and a new parenthesis. Tuck. Let's see. We have another person living here. Okay, let's say this one is way too, whatever, changing it a bit. All right, then I would like to see all these elements. So it's from beginning to end. Okay. And let's see. Okay. So you have here, in fact, it is according to the position where you are, but you went until the previous one. So what you can do here, so you have this list iterator, you have add p. You can also go to the next person. So let's see here. You have this list iterator and you go one by one. And as you can see, you still have this one. Okay, so it would be just before the next element, but you are already on this position 0. So we will have the list iterator of next, and then you can add these persons. And remember that you start from a certain index, such that if you want to have it from the beginning to the end, you would have again this list iterator, such that you have them one by one. Let's see. So this is according to it. Okay, and based on it, as you can see, you have it for your array of persons. And here, when you start it, whether you do not mention for this list iterator, you do not mention your array list, but it is associated to it. So what it means is that you were on position 0, you move to the next position with this next. So this is why you place the new person, which is Liliana, after the first person, which is Mr. Ionel. Okay, and when parsing the whole set, you just see person by person. If you would use this list iterator, you would have to go on the previous position. So always remember that this list iterator, you see it as a pointer, and it's a pointer which is relative to your current position. Okay, so this is why you use this iterator, whether you want it to start from the beginning. Here, this one, you need to manage it and to know exactly where you are. Okay, so this is, so with the iterator, you can go through all the elements. The list iterator is also useful for going from backwards to the beginning, as well as to add elements to your collection of persons. Okay, so this is a list of type array list, because you cannot have a list of lists. List is already abstract, so you cannot initialize it with another abstract collection. And then you go through all your elements. Okay, what you can also do with the list iterator, it also can remove. Okay, so you can have the list iterator with remove. Let's have a list iterator with next. Then I have my list iterator that remove. Okay, so okay, you can see that Ionela disappeared. Okay, because it went to the following element after Liliana. Okay, and then being Ionela, the second record from here, it will disappear because you did run the command with remove. What you can also do is also to set it. So I can have list iterator dot set, and to have my person p2, and let's see what happens in this case. Okay, so it means that you also have this, you have a list which will have the whole element extended. So it would mean that again. So here, when you have this one, it will have, let's say we have a ListIterator next. Okay, so if I put it, come this way, tag. Okay, and this one, it does it in the same way. So it also sets it, it also goes forward. So this is why it doesn't want to display. Because you modify and it is not the same way. Okay, so let's see. Now it went forward and we will have the next person who will be initialized with Ionela. So it means that Mr. Dragos using next, it will be overridden by another object which you provide. So it will be this P2. Okay, so this is the whole playing around, okay, in this one. And also you can even get some name, personal numerical number. So it depends what you want to get. If you don't want to have the whole object and to see it in this way, so you can have get name, okay, and you would receive exactly, okay, the element, I mean the names of all the persons. Okay. And then you were also having this compare the elements. So you have that one with comparable. Okay. So it means that it was, no, that I used comparable. I think it's this one. And it was with card. So as a recap, when you want comparable, you will have to implement it. Okay. So let's see. You have this implement comparable, okay, of person. Okay, being this one, and it will want us to implement the method compare to, and here you need to put a similar logic to what you have here, whether it's before, whether it's after, whether it's equal. So just reusing the code, and let's see. Based on what can we compare? Okay, so this is always before means that it's -1 equal two objects of the same type. 0 after means that we have a 1. So whether they are the same, you just return that they are equal. Then you can compare based on personal numerical number. Okay. And you have the result. Can get personal numerical number. Or what I can have, can even get the address and based on, let's say number. So this one depends on you, how you want to compare them. Here you have it as string, this is numerical. Get, okay, and this one means, alright, attributes, so this is whether CMP equal, which you shouldn't have. Okay, get, in fact it's this one, but you change the sign. Okay, let's see. So you would have to compare them one by one. Okay. So here with the card, compare. Or having this one, maybe it has already. it one by one. Okay, with this object comparison, or you can get it with the iterator according to the previous element, whether it exists. So let's have it going here. Right. Let's have them compared. Compared to person P2. Then you have the person with -1 and so on. So you can get them one by one. You can order the elements based on it. So let's see, the first one with 1, okay, comes in front, and okay, so you just compare between them. And you can compare even here, you can store the previous element, and you can have the comparison each time. So this is what you can do in this example. Okay, you can compare. So it would be done here inside. Okay. Any questions up to now? Let's see, this is person and the driver used for testing. So here with this iterator, you can compare one by one. You can do it with this one. As you can see, you have the current person. You can store the previous person. You can compare them and to say which is the relationship between them, who comes in front of whom. Okay. This is the whole meaning. All right. Then what you can have, okay, is a hash set. So when having this hash set, you have in fact keys, such that for each and every element, you will associate a hash code, which is done based on a hash function that you need to define. Then, based on it, you have this Boolean equals according to another object. But you do it according to your hash code function, okay? So this hash code is like an index that you associate with your object. So it is like here I have the personal numerical number, and I know that the first digit, whether it's 1, it's a male, whether it's 2, it's a female. So this is how I can group them. And this is my hash code function. Okay. Or maybe I want to get the first name, and I know that in Romania, whether the name ends in A or whether the name of the girl is Carmen, for example, which is just an exception. But when ending in A, it means that it's a female. Okay, so you can have different ways of grouping them. All right, so let's see. This is the case when here you have a dog, and this dog has a color. So in this case, you have this equals. Okay, and you compare two dogs according to their color. Okay. Okay. So they are based on similar attributes. All right, let's see about what was the exercise with the product. Okay, product name, description. Okay, so this is the case when you apply the hash set and the hash code. So let's solve it for this one. Okay, so here you have a product, and the product has a private string product name, description, then you have ingredients, and ingredients you also store it inside a private list string ingredients. Okay, importing it. Okay, Java util, and let's add stars. Okay, solved. Expiring date, private Gregorian calendar. It's also in Java util. expiry date. Okay. So let's have the generate constructor. Okay, and let's generate the others too. Getter setter. Check. And here I also generated two string based on all of them. Good. Let's see. As you can see, being a hash set, you need this equals and this hash code. So inside generate, you already have this equals and hash code. So let's see based on what. Yeah, I have these getters. Okay. And based on what you want to get them, fields to be included in the hash code. So you define a hash code based on some fields which you want to use. So you can specify which ones you can use or exclude. Let's use all of them. Okay. They should exist, so they should be not null. Okay, ta-da! And this is what it does for you. So let's see here how it was done for your dog. So don't forget, HashSet is when I have different objects, you have a function, and based on the function, you associate them to an index. So let's think like you've got a dictionary, okay? And when you want to search for a certain word, you just look at the first letter, and based on the first letter, you go to that chapter and you start searching for your word which you want to find out, which is the meaning. And then, in fact, when you want to get exactly that meaning of the word which you want to check, in fact, is this Boolean equals, because what you do is to check letter by letter if the word which you want to have the significance for that one is the same as the one from your dictionary. Okay, so this is, in fact, your hash map keys. Based on the key which is in the alphabet inside the dictionary, I want to find the meaning of the word, exactly the object which I want to search. Good, so let's see. Here we will have a dog, okay, and this dog has a certain color. So whether you want to check whether this dog is exactly the object for which I'm searching, first of all, they should be of the same category, okay? So it means that I want it to be an instance of dog, and whether it's not the case, so you have this exclamation mark, it means that it's false and I don't have why to search in this dictionary, okay? So it would be if your current object is equal to the one for which I'm searching, okay? This one obtained as an input parameter, then the result is true. Then how would I find out that it is really the same one? You can even compare the colors. So maybe they are different dogs of different breeds, but I want to have them per each color and to see which dogs have a white color, for example. So I would compare the color of the current dog from my context with the color of this object, which is in fact of type dog. So this is why I cast it, and I get its color. Then you think like this. When I want to search based on color, how do I search for it? Well, I can also search according to the length of the word associated to your color. Okay. All right, so let's see. Here, when you have your set, you define it based on a hash set. Okay. But until that time, let's see how we did it automatically for our products. So how do I find out if a product is the same as another product that I provide here as an instance? First of all, I need to check whether the current object has the same address behind it. So whether they are identical, then I return true. Then I need to know whether or not they belong to the same class, even if the address space is different. So I need to check whether the instance of the product is of the class of my object is different than my product, then the result will be false. Then I know that the object which I receive here, this O, I can cast it and to have it as my product. And then whether I want to check that they are really the same, I would look at the name, which should be exactly the name of my product name. And here it can be with this equals ignore case because they are strings. So this equals is exactly to be the same, but you can type it also with lowercase. This is the same. Being a string, it's safer to use equals with ignore case. This get ingredients, it's an array list, so you can have it one by one compared, and expiry date, this is done with equals. Then how do you associate the code for it? So you can use exactly, you have a hash function that you can use here. As you can see, it will automatically have a hash code designed for it. Or what you can do, so you can use this function, which is provided to you by Java, or you can have a hash code function according to the length. You can get maybe the month of expiry date, the year of expiry date, and to search based on it, and to have the months counted according to your current date, and to see how far away is the expiry date expressed in months based on your current date. So you can define your own hash code example. Okay, so or alphabetically based on product name, whatever, or based on description, who knows. Okay, so let's see here. Now you will define a hash set for it. I can do it even here inside. So it's a fine take void main, or you can put it in the driver class, in another driver class. String args. Okay, such that here I need to have a hash set. As you can see, when you have a hash map, you have key value pairs, and you already know that based on a key which you define, like here based on A, let's say at letter A I have some value and so on. Or at my product name based on a name, or I can have a code bar like you have while shopping. Based on the code bar, I know which is exactly the product and I can update the quantity. Here is when I have the hash set exactly based on the object which I want to store. So I don't have key value pairs. You just find out which is the code associated to it. So I will have a product and I will have a product set. Okay. According to a new hash set. Good. All right. Then what I need to have inside is to create objects of this type of product. So I have a product P1 as being a new product of what was it? Product name. Chocolate. Then what do I have? Delicious treat. Okay, then this is the ingredients. New array list, and we should have here whatever. Chocolate beans. Okay, but you will have to edit more inside it. And it contains this of type string. And you need to have them placed one by one. Oof. So I need to put it outside. So annoying. Okay, let's have it above. And list of string ingredients P1. It's being new array list, and in P1 I have to add toppings. Okay, emulsifiers and so on, all the other. Okay, let's see, sugar and ingredient P1 that add, okay, vanilla butter, okay, let's have it here. Ingredients P1, and it was with new Gregorian calendar, the expiry date. So it says, yeah, so it is the year firstly, then month, then day of month. Okay, good. And this is one product. And then I will have another product. And let's see. Okay, what? Then I would like to add them. So inside my hash set, the product hash set, I want to add product P1 and I want to add product P2. Good, so they are added inside. Now what I want to know is whether I have P1 with equals, okay, my P2. This one will run the same exercise. So they are not the same. Okay. I put it. Yeah, let's copy paste. Okay, 2, 3. Okay, now we have the same objects. Okay. Then you can even see how many you've got, how many items. See out hash set. Okay, as in total. Okay, I have the name, which is product set, and then I need to call size and elements in total. So when running it, you see that in fact you have 2 elements because you shouldn't have duplicate. So it will check whether by default it knows that associated to it you have this hash code and equals. So this equals knows exactly whether you have the same object and it will not add it inside it. But for your array list, you can have the same instance several times. So this is the case when a requirement says that you need to have just unique values or not to have duplicates. You should choose a collection which is this hash set. So here, by default, it excludes those elements which are simply copies of it. So we can even check whether it contains certain element. So let's see if product set that contains. Now we will have an instance. So we will have this long instance. Okay. So you can put it like this, or you already add P3, the same one. Pretty long. So whether it does, if we say already delicious muffin. Okay. If not, Okay. No happiness. Okay. So let's see if I want to run it. So we already have it. And whatever. Vanilla muffin. Okay. It will not have it, so we lack happiness. Okay. Let's see. And this is the hash code which you can change. So in this case, with this hash code, we in fact have the length of the color, but you can have your own way of saying, like maybe you want to have some random value, so you can write it differently, and based on this hash code you will have different values and it will store it. Okay, so here you have the same white dog. It will say that it has just ones because it shouldn't have duplicates, using the hash code function. And based on the hash code, even here, if I make it return something random, it is less likely that, so you return an integer, that it will be excluded. So we should have random is a number between 0 close interval and 1 open interval. So you have 0 dot and a long number of letters. So this is based on 1 digit. Okay, so if I run it again, okay, this is again based on it. So if we say that it has it, yeah, because it uses this equals by default. Okay, where there is the difference, and this is how it compares it. But you can check, they are also the same. So this is why it excludes. It excludes by default because they are the same objects inside it. Okay. Check. So yeah. All right. Let's see what you had. Okay, okay, so you just have these to implement equals hash code. So this is done for you. Then what we will have is also another example, another collection. So as you can see, you have this kind of collection with a hash set when you want to have unique pairs stored. And you can also have a tree set. So what the tree set does, it also sorts the elements, okay? So you will have to implement the sorted set, but also the hash set is much faster. Of course, it's much faster because it will not have anything. It won't have the sort operation according to it. So whether you want all your elements to be sorted, you will have a tree set. So as you remember, from data structures and algorithms, you are having the root node, and based on the root node, you are adding on the left side elements which were less than the root, and on the right side elements which were greater than the roots. Okay, and then you are parsing it with breadth first search, depth first search, and having the whole elements in pre-order, in order, post-order. Okay. And this is the case when you have employees and you compare your employees according to a criteria. So this is similar to what I did here with this compare to, and you should say based on what you want to compare, CMP name. And let's see, here you have the employee, which is defined. Now let's see, we have a car. Do you have any questions up to now until I start solving, explaining this part? So you can ask, don't need to raise your hand. Okay, so if not, I will continue. So let's see. You can ask the questions anytime. Okay. Here you have a car which is characterized by brand description. You have the maximum engine speed. So we will have a private string brand. Then we have description and let's say private int max engine speed. Good. All right. So in this case, we have all the constructors, getters, setters to string. Same story. Okay, let's have them all, because these ones you should already know them. So it's no point. And the scope of this part of this exercise. Let's see. To string talk based on all. And your car is solved. Now, what I need to do is to have the main string args. Let's see. All right. You want them also to be sorted. And how do you sort? You should sort according to a comparable criteria. So you have the compare to, but it means that you will also have a TreeSet. Okay. So let's see what it does. Okay. First of all, you will have the class. So whenever you want it to have this criteria, you see that here. For it, you need to have the comparison criteria as another class which you will be using. So I have this inner class and what I can do is to have car comparison, which will implement comparator based on what? Based on my car. Okay. And this one, okay, this implements, because else it wasn't finding the keyword. Okay, it will import, and after importing, you should implement the method, which is compared to. As you can see, you can also have the reverse. You can have comparing according to keys, but what I want to do is to have this compare based on two objects of type car. So we can do the comparison based on brands. So I can have this C1, C2, it's better, car1, car2. And I would return car1 dot get brand dot compare to car2 dot get brand. And I can compare based on two brands and to sort it according to the brands of your car. So let's see over here. We need to store everything and to have it sorted, meaning that we have TreeSet that exists inside the library with Java util. And inside it, I will store elements of type car. Okay, so I will have my cars, and it will be a new TreeSet. Okay, set. But when storing it here inside, you need to say based on which criteria do you order, because whatever the sorting, you should define your criteria, and your criteria is in fact my car comparison. So it will be new car comparison. Okay, let's see, this one needs to be imported, and this one. Okay, this one needs to be static to be called inside. All right, good. Then what we have to do is to add new elements in this my car. So I will have to add a new car of what I need to have a brand, whatever, car, the engine, so Then what was it? Maximum engine speed. Oh, okay, and this is one of them. Let's copy. Greater speed. Okay, and class. Okay, so let's see now. If I would like to go through all the cars, my car C that I have inside my TreeSet, which is my cars. Okay, I would like to visualize it, and it will be based on my C. And let's run it from here, okay, because else it will, if I click on this one, it will be the previous one. And as you can see, based on how I did add them, it did the sorting in alphabetical order based on the brands. Okay, you can even sort based on the max speed, so you can compare based on it, or you can add different comparisons. Okay, based on description, which description is the longest or the shortest. Okay, so this is how you solve this exercise. Okay. And you want two objects to be of the same value. Okay, let's say that the first car is twice. So as you can see, like for the hash set, whether you have one object twice, it will store it just once. So remember that inside the array list, you can store the same element multiple times. Inside HashSet, TreeSet, it will store it just once. But what's more interesting is that here inside the TreeSet, whether you also want it to be ordered, you have your comparison criteria and you can order based on it. While in your HashSet, which was this product, okay, it will not order it. It doesn't have any order. You have here inside just equals and hashCode. And these ones, as you've seen, it is good because you can generate it, okay? And you have this equals and hashCode, okay? So this is really useful because it helps you a lot in order to decide. You just modify a bit and you decide your comparison criteria. So you can speed up the whole process because at your exam, at your test, you will have longer descriptions. So you should firstly identify the collections, which you should use the best suited collection, write the whole definition, and based on it, you should know what you would select. So let me firstly paste this one. So as a recap, being an array list, you can store the same element multiple times. When you have an iterator, iterator displays all the elements starting from the first position. Okay, you have the set.iterator, it starts at the beginning of your set. Then whether you want to iterate backwards, you have the ListIterator. You can even add elements, modify elements based on the current index. So the current index is the one according to the position that you reached. Okay, so you have this next and previous to go forward and backwards. Then this one is when you add or you modify an element, it remains stored inside the array to which you did associate it. So as you can see, this ListIterator is associated to your array list. And this is why when I use again this iterator, it will have the updated set. So it is like here, I have a ListIterator. Based on it, I modified it, I added a new person, I did override a person. Okay, so let's run it again from here because I have multiple drivers in this package. And as you can see, they were updated. And I use again a list iterator for it because I don't care about my current index. I don't want to have something like this. Okay, so with ArrayList, you can have duplicates. When you don't want to have duplicates for your collection, then you use a HashSet and you store all your elements according to a hash code. So you don't want to have your objects of the same type, and this is why you define the hash code. So you provide a code based on your object, and you want to see whether it's equals. Whether it's equals, I don't want to use it, so I simply skip it. Okay, and when I also want to have this behavior of the hash set, but I want it to be sorted, you need to have a TreeSet. So for the hash set, don't forget that you need to implement the two methods, which are equals and hashCode, and you can use the generate inside. Okay, so you have this generate equals and hashCode. While for the TreeSet, you don't have this help. This one is based on sorting. So this is why you define another class which will implement Comparator, and you will have the compare method, and you define your own comparison criteria because maybe you want to do it based on a string value, based on a numerical value, or multiple values, or maybe just the first letter, who knows, or some parameter inside your string. Maybe you have it over there. So this is the case of car. As you can see, for it, inside your car, which is done by using generate constructors, getters, setters, and toString, you have this comparator, okay? And you don't need to define your equals and hashCode, okay? Not what you did for product with equals and hashCode, okay? It will simply, you will have the TreeSet, but you will have to provide which is exactly the comparison criteria, and based on it I will have ordered, I will have all the objects which I provide ordered according to the brand in alphabetical order, but as you can see you will not have duplicate elements, so this is the benefit of using it. Okay, so I will stop the recording, and whether you do